Welcome everyone to this episode of the networking channel. My name is Joyce Mwangama and I have organized the event here today. I will give a brief introduction on the topics to be discussed today. The title of this episode is Digital Health in the 5G, 6G era, from vision to real deployments. So my name is Joyce Mwangama. I'm from the University of Cape Town in South Africa. And as I mentioned, I'm the organizer, and we have two very knowledgeable and distinguished speakers on this topic. Our first speaker is going to be Matti Hämäläinen from the University of Oulu. He will talk about the visions for wireless healthcare. And then after that, our second speaker is going to be Pantelis Angelidis from the University of Western Macedonia, and he will give a talk on healthcare use cases enabled by 5G technology. So without further ado, I will now hand over to Matti to give the first talk. Take it over.
Okay, thank you, Professor Joyce. And I'm happy to be here. Thanks for invitation. I will now share my screen. Hopefully you can see it and then put it in presentation mode. Now it should be visible. Okay, first few words about myself. So my name is Matti Hämäläinen. I come from Center for Wireless Communications, University of Oulu. We are belonging to Faculty of Information Technology and Electrical Engineering. And you can see from the map where Oulu is located. We are here in the middle of Finland. And I'm here working as an adjunct professor and university researcher. My research interests are ultra-wideband technology, wireless body area networks, medical ICT, radio channel measurements, and modeling. Those are the topics I have mainly worked during my career. And then some key highlights. I'm one of the founding members of ETSI Technical Committee Smart Body Area Networks, which is defining European standard for smart body area networks. This work started in 2013, and still the work is going on. And then I'm a co-chair of International Steering Committee of International Symposium of Medical Information and Communication Technology, ISMICT, and I'm used this opportunity to make a marketing announcement. Next ISMICT will be in Osaka at the end of September, so you can find information from this website. But then going to the topic itself. So first few words about motivation, why we need wireless in healthcare systems. We know that this demographic prognosis is not so good at the moment. We are having fast aging population, which means that there are long retirement times, which means also that there are less people in working age. And when people get old, the chronic diseases are increasingly and really badly. And from the table here or chart, you can see that during the last year, the number of people having age more than 65 years has increased quite fast. For example, in Japan, almost 1/3 of the population is 65 years or older. In Finland, almost 1/4 of the population. So this is really a problem. But it means we need a lot of funding to support our healthcare systems. So this is motivation. We need technology to assist healthcare professionals, and so that they can provide services in such a way that people can stay outside of hospitals as long as possible. Not only patients, but elderly care and other care units. When people are not hospitalized, it means that the quality of life is improved. It also enables mobility, which is good from caring side, and all outpatient people, they are reducing caregivers' workload. So we can give care for those people who are needing it if people are not hospitalized. So reducing cost and improve hospital efficiency. This is one way what is really important. So modern technology enables people to take more responsibility of their own health and well-being. So we can start from that point. And what it means that we need energy efficient, seamless, and reliable wireless technologies that enable remote patient monitoring and healthcare service provision for outpatients. We need lightweight sensors, actuators, which are connected to internet, so that we can monitor different vital signs during the day. That enables us to collect data to be used, for example, behavior data analysis. We can detect possible changes, abnormalities on your daily activities. We can enable alarms and interventions when needed, when people are 24/7 monitored. And what is good thing is that this kind of operation can be location independent. And when we are collecting huge amount of data from patients, we can also save it to electrical health records when we have appropriate communication technology available. So this is helping both for patients as well as healthcare professionals. And how we can see this at CWC Oulu, we are thinking that using of wearables and wireless body networks is one way to collect and transfer psychophysiological data as well as activity information throughout the day, 24/7, which means that we are also able to provide updated data for healthcare professionals when they need it. This is one actually old figure where I illustrated where we can use wireless technology. So we can have at hospital wireless sensors, wireless monitoring devices. We can use wireless techniques in operation theaters during the data transmission and so on. We are able to track people, devices, and so on in hospital. All the data goes automatically to health records. And most importantly, the doctor, when he or she comes to meet patient, it's possible to provide the latest medical information using wireless technology and wireless, electrical devices like PDAs or tablets or so. This also improves remote care, prevention, aftercare, and so on. And when we are collecting all the information, stored it in database, we are able to use medical AI. So this is also improvement for population health approach. So I have called this ubiquitous wireless playground at the hospital. But some parts of these approaches, they can also be utilized at home. So this kind of systems, which are not targeted only for hospital use, but in wider use, they are helping, for example, industry to provide those systems, gadgets, and so on. So this is one way how we have identified this kind of wireless data collection in medical healthcare applications. We have here a person who has a lot of sensors, actuators, depending on the case. Of course, no need to carry 40 sensors or actuators. Having smaller set of those is enough, depending on what medical symptoms there are or there is a need to check. So we do sensing. We are talking about personalized monitoring, which can be done manually, but we can do it automatically using various wearables. Then we do analysis, which provides us data for early detection, and this can be done by the device itself, or it can be distributed for different servers located in different places, and then we can give feedback, early warnings to user. And this example is for local analytics, which means that we collect the data here and then do communication using some dependable communication technology, doing it automatically or manually. And then we need to protect data because we are dealing with medical data, which need to be secure, and it is not tolerating any faults. So we need to protect it fast. We can use DLT, blockchain, whatever technology, and we need to protect all the chain from the sample to the communication chains up to doctor as well as electrical health records. And when we have this kind of centralized data record, it's possible for a medical professional to get ubiquitous access when the data is needed. And of course, there's a possibility for other doctors to consult having the same data. And then finally, we are able to give professional feedback, help, and support for emergency cases, for example. And then when we have all of this, we are able to have some societal impacts also, which is really important. So we are able to develop new efficient healthcare processes, new services. We are able to increase outpatient safety and having cost reduction and new business. So this is one way, and then other way is when we first communicate and then do the analytics. So we are now in cloud-based system. More data is analyzed in a cloud services, not locally. So two different approaches, and they have their own pros and cons. So what we are doing at GWC, we have done a lot of research developing dependable end-to-end communication and computing solutions for future healthcare solutions. So basically, we have started from wireless body area networks. Our main focus has been in physical medium access control layers, WiMAC, but we have also studied higher layer solutions. We are studying new radio technologies, including 5G, 6G, non-terrestrial networks, optical wireless communication, and also hybrid optical RF communication, including also visible light communication solutions. Very important thing in transceiver design is the knowledge of radio signal propagation. So we have done a lot of studies relating to WPAN and hospital radio channel modeling. Antennas are needed, antennas for wearables. It's something what we are also doing. So medical IoT system starting from antennas, radio, and then data processing. Medical AI machine learning techniques, distributed ledger technologies are also included in our research portfolio. Secrecy are important things, and they should be taken into account in all the application, independently being medical or not. Then service and network function, virtualization, orchestration, distributed computation, architecture, so edge cloud continuum, they are recently heavily studied. And finally, having performance analysis using various KPIs. This also includes interoperability studies. So these are some functionalities what are needed from radio research point of view. Then there are, of course, other disciplines coming from sensors, batteries, and so on, what need to be taken into account. So medical ICT as such is multidisciplinary collaboration, and we need to involve also medical people in these kind of studies. At CWC, we are having a 5G, 6G test network to support experimental research. So we are also a mobile network operator. So there's a link if you are willing to see further details about our network. So please take a look on that. I'm not going to discuss that more in this presentation. So wireless body networks, they are providing a solid platform to collect and transfer vital data from person to medical and healthcare professionals. So we need multiple sensors which are non-invasively taking samples, whatever is needed. Nodes need to be small so that you are willing to carry those, and basically maybe 4 to 6 sensors is maximum what you can or what you are willing to carry, but the standards they are allowing you to carry more. And basically typical WPAN is formed in such a way that we have a central unit, we call it as a hub, which is the most powerful device in the network, and the different remote sensors, they are connected to hub using a one hub start topology, and then hub is connected to network. And there are different suitable wireless technology available, and Bluetooth Low Energy is at the moment de facto standard. Of course, because we are doing and contributing to ETSI smartband standardization work, I hope that someday also smartband is taking some role. And of course, cellular technologies are there. This is for WPAN, and then connecting to backbone network from the hub side. There are also a lot of technologies available. Then we have collected data, we have transferred it to somewhere. First, we have data processing and storage, which is done locally. Okay, this is very simple way to give instant personal feedback. But then if we start to collect information from sensors here, using our guy here, sending data to cloud services, having some information to control actuators, this is reflecting to, we call it 4G approach, so that cloud services are collecting data. The analytics is done there, which means that the latency is not always the optimal one. We are also having security flaws and so on. And we need to take into account that system security is as high as the lowest security level of the system. Then next step is that we are going to two-tier edge services. So we are calling it as a 5G approach. So we are now having edge services and global services. In previous approach, these were just integrated in the same service. So cloud functionalities are distributed between global and edge services servers, which means that the traffic in channel, radio channel, for example, decrease. We have less possible security flaws, and we are able to decrease latency. And this approach also enables private network structure. The next step, going to 6G approach, we call it three-tier edge services, when we take also local functionalities. So we are distributing services which in previous case they were included in this edge services. They are now distributed to local services. So we can decrease latency, we can decrease traffic in a radio channel, we can improve security highly. So different technologies are available, and those can be used in its cloud continuum approach. So final achievements or goals, we are willing to increase fault tolerance, privacy, secrecy, as well as resource efficiency, decrease latency, energy consumption from device and application point of view. So many things to take into account. Then we have also thought how distributed edge intelligence and edge services can help AI, ML, so we can have different tiers, or different tiers can host different distributed federated learning models to improve AI performance, efficiency, privacy, and scalability. So small latency for decision making, but also AI can help edge services in such a way that we are able to optimally place the resources, services, and do the orchestration. And distributed trust management also gives us possibility to have more reliable network, so that there are no flexible central points for failure. Then I have an example about private 5G standalone hospital network. At Oulu, we have brand new Oulu University Hospital, which has a goal to, or actually it has the first European private 5G hospital network. And target is to have the smartest hospital in the world. So this work was done in Hola 5G EU project, and it's included in our hospital district's Future Hospital 2030 plan. So 5G test network, which was designed and implemented to provide secure, high capacity, low latency wireless connectivity at hospital for testing and evaluation use. This network is not in operative use at the moment, but targeted for evaluation, use case verification, and things like that. So hospital was opened 24, so it's actually a little bit more than 1 year old. And how it looks, we used to have this kind of mass of buildings, old Oulu University Hospital, and nowadays this part has demolished. We have new hospital here, and the installation has been done in this building, and in 2030 we should have new hospital campus like this. So this is University Hospital, which is run by hospital district. How we have
Then we have gone over time.
Okay, few examples how we have implemented 5G network or private network in hospital. We have own core network there. We have baseband units, radio heads there, but everything is duplicated. So our network or the hospital network should be quite prone to malfunction. If core breaks, we have another core in different building. If basement unit breaks, we have something to replace it. Also, the coverage is provided by duplicated radio heads. So this is how the operation is guaranteed. And it has been implemented in different neurocenter, heart center, neurology, operating theaters, and so on. There are some small information about the system, and then we are providing tools for hospital people to do those tests. There are, for example, wearable technology taking into account. There are smart glasses to visualize vital signs and so on. So increased security, secrecy, trust, those are really important things what we need to take. And in private 5G hospital deployment, data is in your own hands. So no, it's much more secure than the cases where we are collecting all the data to clouds. Okay, I need to skip. We did some measurements. We studied how those operating networks are causing what kind of interference in new hospital before private 5G network installation. And after that, an old hospital where we didn't have 5G network, yeah, that private one. And here are some figures and how we did those measurements using a spectrum analyzer. Here are some results. So we noticed that we are providing signals which are nicely in safety zones. So conclusion, wireless healthcare, it consists of several domains, data collection, actuators, and we are hoping to use W-bands to collect the information to provide mobility and so on. Data transmission, there are various technologies available. Distributed data processing utilizing AI, ML, S-Cloud Continuum to decrease latency, improve security, and so on. We know that in hospital environment, we are facing with really tight performance and operational requirements. Okay, that was my final slide, and then due marketing in Oulu. Next June, we have Roddy conference on digital health and wireless solutions. Paper submission time has been ended, but if you are able to come, please come to visit us. And ISMIT conference will be next September in Osaka, Japan. Paper submission will be open in April. Okay, thank you.
Thank you, Matti. That was very comprehensive and shows a lot of the work that you've done there at the University of Oulu. And I'd encourage the attendees, if you have any questions, please pop them in the Q&A. But without too much more delay, I will introduce now Pantelis, who has the floor to give his presentation.
Yes, thank you, Joyce. Hope you see the slides. So, thank you for the opportunity. Hello, everyone, whichever time zone you're in. What I plan to present today is a couple of real-life use cases, as we call them, of 5G-enabled healthcare real-life applications. A few things about the two hats I carry, the academic one. We are a small, I would say, lab in a small, definitely small university in the northwest of Greece. what we are good at is health data. We know how to collect them, aggregate them, process them, and then visualize whatever knowledge we extract from them. Few faces here, always useful. And Vidavo's mission is to take the research outcome and make it innovative products in real life applications, so solving actual problems. It has been in operation for more than 20 years now. And the main, let's say, the flagship product is a health IoT platform called Vida24, who has been named by independent evaluators within the top 100 platforms globally for quite a few years now. Okay, Matti, I think, gave a great introduction on what are the expectations of 5G in healthcare. If I can put it in a nutshell, is three things. It's reduced latency, higher bandwidth, and more secure environment. Let me put it this way. So what I'm going to, as I said, I'm gonna present to you some actual applications that we've done in the last 5 years or so. The first one is 5 years old. It started as a smart ambulance or connected ambulance. The idea here is KYP, like the KYC, know your customer. Here we call it know your patient. So the idea is to take advantage of the transfer time that you have the patient in the ambulance so that the emergency unit understand what is coming in. And then in the process, they realize that they can, if they have a video call with paramedics on the ambulance, in some cases they can also start some kind of operations. I'm not sure this is the correct word, but anyway, while still the patient on the ambulance. Then the idea was that once they arrive at the emergency department to seamlessly transfer the monitoring process in the ER. And that was late 2019, and then COVID came. Yeah, this is the setup of the ambulance. I think it's a no-brainer that low latency, high bandwidth is important here. So actually 5G proved to be much better than other options, like LoRa, for example, which was starting gaining up some momentum 5 years ago. And then, as I said, COVID came, so the ER units were collapsing, receiving way more people than their capacity. So what we did is the problem that they were facing with this huge number of people is, first of all, they were, at least in the beginning, were not very sure what exactly is this kind of the illness and how you should address it, because everybody was coming with the same, more or less the same symptoms, but um, the progress on each patient could vary from no treatment needed to put them in the ICU as fast as possible. So what we did is we created this, we developed this quite cheap wearable that was measuring heart rate and oxygen saturation, the two more important, let's say, vitals for COVID at the time, and also had location capability because uh, patients were lost because they were flowing in huge numbers. Then they didn't have where to stand. They would go to the cafeteria, to different wards of the hospital, outside in the park or in the street, or go back home. And what this wearable was doing was doing a very quick processing in the at the edge, and then aggregating data in the cloud. And after some time, we were able to have a prediction score of what is the probability of the specific patient to deteriorate quite quickly, because the curve that they were seeing was some kind of stable condition, and then a very fast deterioration. So that proved quite useful. It was lucky because we were at the time on site because of the ambulance project, and we were able to develop this one. And actually, the aftermath statistics of this hospital in terms of how they performed during the first crisis of the COVID, the first wave, was quite much better than the rest of it. Yes, as I said, Matt explained all this. We had sensors, actuators, the communication part, and then edge computing for the patient, and we had cloud computing to train the machine learning module. Then COVID, vanished or almost vanished, and so did the application. But they're still operating a decision support triage system for now, normal emergency care. Normal, I mean, non-COVID related. So that was 5 years ago. Another one that is currently ongoing is it's called 5G Trace. It's funded by the European Commission under the CEF program. For those of you non-familiar with the European jargon of funding, this is money flowing into European Union member states to demonstrate modern or advanced communication network capabilities. So this 5G Trace is specifically for 5G in healthcare. And we are subcontractors of a subcontractor of one of the NetOps of Greece, Nova. We have three of them, three 5G operators. One of them is called Nova. This is how it is built. Actually, in Greece, you cannot license a private 5G network yet. I say yet because my guess is at some point someone will decide to build a regulatory framework to allow this. The only license you can get at the moment is a temporary research license, so mainly for universities and research centers. So this has to be built because of that, because we wanted to be, or the people wanted to be, or the funders wanted to be a real live installation, not a research one. It's built as an extension of the network, and as you see, it's EPC, so it's 5G NSA. So strictly speaking, it's not private, it's not 5G, but that's only for network engineers. As far as the hospital management, the net top marketeers, or even politicians, this is a 5G, a private 5G network. So I guess it's a matter of perspective. And yes, this is how it's sectorized. This is an 11-store hospital. For those of you overseas in Europe, ground floor is 0 and basement is negative numbers. So just a matter of notation. The two top floors is management, administration and operations, so they don't get any 5G, at least not from the private part. All the other are clinical floors, so to speak, so they get it. And this is a map of the antennas on the ground floor. So we are running 5 use cases. I chose to show you 2 of them, those that are the most, how should I put this? Those that are the best music in the ear of the 5G enthusiast engineer to promote healthcare 5G. So the first one is a smart bed. Everything is smart these days. Matti explained already this. This is actually a matrix of pressure sensors that we put on the bed for patients that, for whatever reason, they need to stay on the bed for very long periods, and because of that, they have the risk of developing ulcers, skin ulcers. So what we do is we actually measure the time of the different parts of the body that are in contact with the bed, and create these pressure maps, which actually show the probability of developing ulcers in different areas. And then the idea is use historical data as well, train the model, and make again a prediction. And the idea is that you change the geometry of the bed, of the matrix on the bed, so as these areas that are more heated, and you see this color categorization, red means high probability to develop the ulcer at this particular area. So the idea is to change the geometry and keep the body, the parts of the body that are come in most of the time with contact with the bed less than that. Also put some kind of preventive solution on these parts of the body and stuff. That's the one use case. And the second one is the smart infusion pumps. The hospital, apart from the main building, they operate a separate daycare facility on another building a couple of miles away from the main building. The idea is that people that do chemo and no need to be hospitalized, they come to an environment that does not look like a hospital, so it looks like a community center, a hotel, whatever. They can come in with their families, socialize, and then have the treatment. The idea here is that we measure not only the pump itself, so if it functions well. In some cases, they have to alter the rate of dosage infusion, or change the cocktail of the drugs or whatever. But also we measure through a similar wearable as the one that I showed you for the triage case in the COVID. Um, Heart rate, respiration, and oxygen saturation, I think. And through this, we calculate the stress level of the patient and create again some kind of alerting in case that the system thinks that someone should intervene. And the idea is that all this is monitored from the main hospital building. So, so we have a 5G to 5G private network through the core network. This is not yet built, but uh, we're in the process of building it. It's a little bit scary in terms of a use case for the patients and their families, in the sense that the pump is controlled from a distance. But it's not actually the case. There will always be someone on the spot for whatever support is needed. But imagine it back in the hospital as a big room full of screens like these sci-fi movies where you monitor different pumps and patients through let's call it a control room. This is definitely let's say, the happy case for the 5G engineer, because we definitely need high bandwidth. The plan is also to install a two-way communication video, so people can talk to the patient directly. Latency is important here, especially since we go through three different networks. The one in the daycare facility, the core network in between, and the network in the main hospital building. And of course, security is always a crucial issue when it comes to health or life, in this case, maybe related data. So yeah, it was quite. I mean, let me put it this way: we are very much looking forward to this use case. How am I doing with time, Joyce?
About 2 minutes left.
Okay, all right. I'm almost done. These are some screens of how this control room would look, with many, as I said, pumps and patients monitored one next to each other. Vida24 is this health IoT platform I talked to you about. Yes, and we have it also on the app for the patient and the family, the informal carer to monitor it, as well as some extra functionalities like chatting with the doctor and things like that. And the wearable, it's a little bit more advanced, so to speak, than the one that I showed you before in the triage case. Yes, I think that's all. You can contact Vidavo people on the left-hand side of the slides, and people in the university on the right-hand side, and me on both sides. Thank you very much.
All right. Thank you both for those very intriguing presentations. I'm now going to call for the attendees. If you have any questions, please type them in the Q&A. We have one question here for Prof. Pantelis. How good are the current integration of 5G 6G use cases for emergency telehealth situations and ambulance in the real world? How are the approaches or architectures like Open RAN contributing to improvements or evolvements in such applications?
Yes, if you said in the world, then I would probably have to improvise because I have no idea. But I can share with you our experience with the pilot that we run here. I think it's very well received. The network responded quite well in most of the situations. Naturally, there are cases where we have blind spots, and um, there's not many things that you can do as the ambulance passes through. You'll have to wait a little bit and rely on your installation, on the software part of the installation to take care of these blind spots. But within a city environment, as the one that we tested it, I think it's very reliable and very, I would say, beneficial for the ER people. At least that was the feedback that we got. And what was the second question, Joyce?
How do approaches or architectures like Open RAN, how do how can they contribute to such applications and use cases?
Yeah, I mean, all options are open, if I may say so. I don't think we have currently a winner, if that is the question. So my guess is that we will still be witnessing different types of infrastructure being utilized. As I said, LoRa came up as a possible alternative and has been tested quite extensively. Um, I would say that 5G definitely presents benefits over all other options, but as I said, we are seeing different kind of infrastructure serving this type of use cases.
Okay, maybe I can ask the same question to Matti. As you have an operational test bed, do you integrate things like Open RAN in the application or in the infrastructure to support these applications?
Yeah. Currently, what has been implemented in our hospital building, so the 5G private network is based on Nokia system. So it's commercial gadgets, but we have 5G test network at our university premises, and we have both Nokia devices. We have also open core, open run implementations. So we are able to do experimental using both ways.
Okay, thank you. We have about 5 minutes left, so if you have any questions, please type them. There's one question here. There's been some work on embedding machine learning models to networking hardware such as switches and edge gateways. Do you see this as something that can help process some of the patient data to where it is generated? I guess it's about edge processing. Maybe.
Yes, if I may try to answer this one. As I said, the first use case that I presented is definitely an edge computing component in the sense of processing the continuous monitoring of the vitals and then sending an alert only when the algorithm decides that predicts, it's a better word, predicts that there's going to be a deterioration of the specific patient. Now, if I understood the question well, was that there is already installed machine learning components within the switches and routers, and whether this can be used. If that is the question, I have not seen anything like that. So using what is already there for the application, if I understood the question correct, I haven't seen any of this type, but why not? I mean, we can try it. But
One,
edge computing for sure, we have seen it working very well.
yeah, one, if I may, one comment. Uh, we have done some collaboration work with our university hospital. There are use cases, for example, when we are dealing with imaging devices, so they are producing huge amount of data. So there, this kind of edge and distributed computation can be beneficial. So we can do some initial analysis on site and then decrease also the traffic in the radio channel, which means we are not so producing so much interference to other users at the same frequency band.
Okay. All right. Thanks. I will ask a question. Maybe this will be the final question, and it's more of a future forward-looking question. And maybe Matti, you can start it, then Pantelis, you can follow on. How will 6G, because we don't know what 6G is yet, but how do you envision 6G's architectural design or implementation will improve healthcare? Do you think that is the case? What are the possibilities compared to maybe current 4G or 5G private hospital networks?
Yeah, I think the key point are coming the features what both me and Professor Pantelis already mentioned, so that decreased latency, improved security, and different kind of use cases. We are able to transfer a larger amount of data, having those security, latency requirements also in the top level. So I think this is really important thing, and then taking into account this distributed analytics possibilities what this can provide.
Okay.
Shortly.
Thank you. And Pantelis?
Yeah, I think as we are able to gather more and more data, bigger and bigger amounts of data, 6G will come into perspective for the reasons that Matti explained. Security is definitely a key issue here for obvious reasons. So yes, I think what the future will bring is vast amounts of data needed to be communicated, processed, and visualized. So yeah, I think at some point 6G will come into play.
All right. Thanks both for your very interesting and timely presentations and for the Q&A. We've now come to the end of our session. I would like to thank the attendees for staying and engaging. I'd just like to announce that the next networking channel event is going to be held on the 11th of March, and the title is Connected Space and challenges and opportunities in satellite computing and networking. We have 4 panelists scheduled, and the event is organized by Professor Jim Rose. So that takes us to the end of our session. Just a reminder to everybody to sign up for the mailing list, follow us on Slack, and all recordings, including this one, have been uploaded to the YouTube channel that you can go back and look at previous versions of these events. So thank you, everyone, and yeah, we'll see you next time.
Thank you.
Okay, thank you.